let's work through this example. Consider the function f of x, which is equal to x squared over the interval 0 to 2. So here I have the x squared parabola, but I only care about it between 0 and 2. And let's answer the questions. A, check that the hypothesis of the mean value theorem is met. So the hypothesis of the mean value theorem is I have to have a continuous function on that interval, which f of x squared is continuous over that interval, and it has to be differentiable between 0 and 2 as well, which it is. The derivative is equal to 2x, and that is nice and continuous on that interval. So it's a continuous function on the closed interval. It's differentiable on the open interval between 0 and 2. By the mean value theorem, there has to exist a c value somewhere between 0 and 2 whose slope is equal to the average rate of change of this function. So this is what B is getting at. There must be a point C somewhere between 0 and 2, right, somewhere inside this interval, which has a tangent line equal to the average rate of change between 0 and 2. So let's calculate the average rate of change, the slope of this line. Change in y over change in x. The y value here is 4, right? 2 squared is 4. The y value here at 0 is 0, because 0 squared is 0. The change in x values is 2 minus 0, right? Just finding the slope of that secant line right there. And we have 4 divided by 2, which gives us 2. So on average, this function increases at a rate of 2. And that's what the mean value theorem is all about. It says that there has to be some point inside the interval 0 to 2 where the slope of that point, or the slope of the function at that point, is equal to the average rate of change. So part C says, let's actually find that point, right? The mean value theorem says that there has to be some point. Now let's actually find it. So I really am just going to set up this equation. I want my derivative to return a 2, and I'll look for which x value that gives me. So my derivative needs to return a 2. My derivative is equal to 2x. So this tells me that x is equal to 1. So let's clear up this graph here and tell ourselves what just happened. The average rate of change over this interval of this function is equal to 2. The intermediate value theorem, because we can apply it, right? The intermediate value theorem's hypothesis is met. It's a continuous function and it's differentiable. Therefore, there has to be a point somewhere between 0 and 2. In fact, let me switch colors. There has to be a point where the tangent line is parallel to the average rate of change. It gives us the same slope. And part C told us that we should draw the tangent line when x is equal to 1. So the derivative when x is equal to 1 is equal to 2, guaranteed by the intermediate value theorem.